Hello everyone, my name is Alex. I'm from AAEON. The topic today I want to talk about is the step into AI and edge applications. First of all, I want to introduce the AAEON. Actually, AAEON is the one of the ASUS group. ASUS merged the AAEON in 2011 because AAEON has a very good branding industrial automation market. Okay, so what we AAEON offer? We developed a lot of the embedded industrial grade CPU boards and the systems. For example, we developed the embedded boards such as the 3.5-inch, 4-inch, and the Congress Express modules. And we also developed larger CPU boards such as the Micro ATX and Mini ATX. Except for the CPU boards, we also developed a lot of the systems. We developed the embedded, the fanless box PC, HMI, and the panel PC. We also developed the network appliance and the NVR. Except for that, we also developed the ruggedized tablet PC, which can be used in the warehouse and in the military. We also have the design and the manufacturing services. Except for this hardware platform, we align with a lot of the software partners. We come out with the solution and we provide the total solution to our customers. So that's what AAEON can offer to our customers. So we select the 5 major markets to be our focus. The first we select is the smart manufacturing, intelligent transportation, smart retail, and the smart healthcare, and we also select the network security. So these 5 major markets will be our focus. And today, the topic I want to talk about the AI at the edge, because we think that edge computing, the market is kept booming. So we know that in the AI applications, there's AI in the cloud or AI in the edge. But we selected the edge computing. We talk to the customers as long as our customers, they have the 3 major, the key features, they will be the edge computing. The first one is the fast response time. For example, if we are talking about the self-driving cars, and when the car had the accident, they need to respond very fast. So in these applications, customers will select edge computing for that. The second key factor is with privacy. For example, there's a lot of the LCD manufacturers. They're very important parameters. They want to keep it locally. They cannot put that in the cloud. And the third key factors will be the reduce the data acquisition cost. For example, in the past, the city government, they will build up the highway surveillance. They will build up the fiber network. But now they want to reduce the cost of building of up the fiber network. So they will do the video surveillance locally. They just, if any car violates the law, the AI will just record it and send back the pictures, and the call license plate back to the central control room. So the city government can save the cost of the data acquisition cost. So for this all, if customers they needed these 3 key factors, they will be our target customers for edge computing. So what are our target market? We talked to a lot of the customers, and we talked to the marketing researchers, and we come out these 5 major the markets for edge computing: retail, security, smart factory, and the parking, and home care. AAEON actually we talked to many the end users, and we found that there will be the 4 major process when we need to work with the end users to go through. The first one is the pain point analysis. And because we need to know the vertical market, we need to talk to every vertical market. They have different pain points. So we need to know that, and we know that clearly with just how we can provide our AI solution to help them to solve these pain points. And in the second stage, we will make the benefit analysis, how much cost they can save, how convenience they can achieve, and what kind of performance they can do. So we will make the benefit analysis how our AI solution can help them. Okay, as long as the customers accept this, we will go to the next stage, POC, Proof of Concept. In this stage, customers might spend the money to buy 1 or 5 sets, and they will put the AI solution in real test, locally in real test. So after they accepted the POC, we will go to the final stage, fine-tune. In this stage, we will adjust the accuracy rate. We will fine-tune the overkill rate. Even worse, we need to change algorithms. So after all this process has been done, the project we can help has been done. We can help customer to solve their problems. So for next stage slide, I will take one example how we help customers to solve their the problems. The example is the auto parking and the payment system. Actually, this project is in Taiwan. You can see that when the vehicle goes through the entrance, the license plate will recognize their license plate, and they will charge your credit card, and then the parking barrier will be lifted. So this is very simple applications. So in the past, their system structure will be like this one. They use the Core i7 box PC, and they install a very expensive video capture card. And the camera send the data streaming to the video capture card, and they use the rule-based license plate recognition software to identify it. So after they identify that, they will send the license plate to the payment server. The payment server will charge the credit card and send the OK back to the box PC, and the box PC will send a command to ask the parking barrier will lift. So this is the old system structure. In this, we talk to the customers, and they tell us there are 3 major pain points they are facing. The first one, the recognition rate is very low because in the sunshine, in the night, in the rainy day, in the foggy day, the rule-based license plate at the recognition software cannot detect it very clearly, so the rate is very low. And if the license plate is non-uniform, for example, the different colors, different format, the recognition rate is low. And the second pain point will be a non-flexible system architectures, because in the rule-based software, then you need to install the light, the camera in right position. If there is a slightly different view angle, obstacles, the recognition rate is low. And the third pain point will be the very expensive total cost. Here, I'm talking about the total cost because it includes the unit cost and installation and the maintenance cost. So we come out our AI-driven solution. We propose that to our customers. So this is a new system structure. In the structure, you can see that we use the upper lake and plus the Mirax. And we use the AI-driven license plate recognition software for them. And we also add 1 car detection sensors, which means that when the car is approaching the entrance, the sensor will detect that. And the sensor will just ask the camera to start to record that. So the computing power can be less. So that's why we can use the upper lake. We don't need to use the Core i7. Okay, and then they will send the license plate back to the payment server, and the payment server say okay, and the parking barrier will lift. So this is a new system structure, and we go to the next stage. We make a benefit analysis to these customers. Okay, the first the benefit will be the recognition rate is high. Okay, and this software can be underrun in any weather, foggy day, rainy day, sunny night, and in any license plate. This is the first benefit we can do. The second benefit is that they can extend their business from the basement, the parking, to the outdoor, to the highway surveillance. Even more, they can extend the business to the different countries. Here you can see that there's actually this application is located in Taiwan, but they extended to the Middle East. The Middle East, the license plate in the Middle East is different, Russia. Okay, so they can extend their business. And the third, the benefit is very important, is that the cost, the total cost analysis. And here I want to emphasize that for the AI-driven business, there's the cost will be higher than before. First, because customers need to collect the photos, they need to make the labeling, and they will make the training. So the cost will be the 20% higher here. But their unit cost can be the 40% off, because you remember that they buy a very expensive video capture card. But now they can use the Apple Lake, Mirrorx, and software license. Okay, so there will be the 40% off. And the installation fee and the maintenance fee can be the 15% off. And there's another very important key feature. They need to keep the same camera. They don't. The end user does not want to buy a smart camera. They want to use the existing cameras. So we can keep the existing cameras and use the AI-driven solution for them. So after accept that, we will go to the next stage, POC Proof of Concept. In this stage, there are several items customers need to check. First of all, they need to check accuracy rate. And another important key factor is overkill rate. And the response time is quick or not. Okay, so if our accuracy rate can meet their target, for example, they want a 99.6%, can the the solution can meet their target? And the second, they will check the compatibility. They will check if our solution compatible with their hardware interfaces, such as the camera, server, sensors. And the second, they will check there's the software compatible. Back-end payment, the software is very important. Users will not change that. Our solution must be compatible with it. And the second they will check is the OS. In the past, maybe they wouldn't use the Windows, but now they use the Linux. Can their software can be compatible with Linux? They will check. Okay. The third one is combination protocol. For example, they use the MQTT, use the FTP protocol to access the images. Okay. And third one, they will put that in the real on-site test. For example, the outdoor parking, they will test that under the summer. For example, their environment temperature is around 60 degrees in the cabinet. Okay, so they will test that if all the functions is okay for them. So in this stage, customer end users is willing to pay few money, okay, to buy 1 of 5 sets. And if all the tests are testing well, they will go to the next stage, fine-tune. In this final stage, we will lots of things we need to do. First of all, we need to collect many photos of the vehicles in different angle, in different weather, and in different format. We need to collect that. And then we will do the pre-process quality of the testing photos. For example, there are some photos which is the overexposure, and some photos, the license plate is full of dirt, and the painting is losing. So we need to remove those the photos, and then we need to check. We need to pre-process the quality of the photos. The third things we need to do, we need to enhance the quality of the labeling. Sometimes sometimes we mislabeling from the A to B. So if we mislabeling, this will impact the accuracy rate. And the worst things is we need to change algorithm. In these examples, in the beginning, they used the RCN neural network, but in the end, they need to use the mask RCN. So the NR in the beginning may be the $10,000 US, but if they need to change the algorithm, they will be the one that might be there with the $100,000 US. Okay, so after all this fine-tune down, we can have the project down. Okay. In next slides, I will take several examples. We are working with the end users. These are real cases. This is the roadside parking. There's the city government. You can see that the golden bar there. Okay, they put the golden bar along the road. They don't want to hire the people to record it. They want to hold a golden bar in the road. There's cameras in that. When the vehicle want to park there, the camera will check the license plate, and they will send the license after they recognize the license plate, send back to the central control room, and they will charge you. Okay, and this is a very good idea, but in the end, this project fails. Why? Because people use the chewing gum to cover the cameras, so the camera cannot detect the license plate anymore. So one of our partners, they are very smart. They put the camera and the AI box in the 6-meter high. Okay, so if you see the slides, you can see that from the 6-meter high, the photos of license plate will be distorted. Okay, so and the city government always asks the partners, they need to identify the license plate in the sunny day, in the night, in the foggy day. Okay, so these partners come to AAEON because they want the ruggedized the box PC because the boxer is located in 6-meter high. If it fails, the software company, they need to hire people to climb to the 6-meter and to change that boxer. No AI software company, they want to do this. So they want to ruggedize one. So we provide them the upper lake with the 2 Mirax, and the system can be run under the 60°, and in the 60-meter high, there's a lighting. So we will design the power protection for lighting protection and the power input protection. So this project, the customers already deployed the hundreds of pieces in the city. Okay, so this is another application. I would take another example. AAEON has a big account, OEM the account. They own our vehicle boxer to be theirs. So if you see that slides, the big account announced that the AI box in the CES 2019. You know, you see it. You know that. Okay, so they put the vehicle boxer. They put a camera at the back end of the dump trunk. When the dump trunk they carried with the dirt was dropped to the road. They put the camera to monitor if the dirt dropping to the road. And at the same time, the vehicle boxer can also detect if the driver is fatigued or not, and do the fleet management. So it is a multi-purpose vehicle boxers, but now customers want to put the AI function in that. So this is another very good example. I will tell you this example is small factories. You can see that the customers use the Core i, the CPU, with the 8 Mirax. So in this process, customers use the AI box in the incoming parts defect inspection. For example, they check if the steel plate, the surface, if there is scratch on that. Okay, and in the assembly, semi-assembly, they will use the AI to check if all the process has been assembled in that. And at the finish the product inspection, they will check if all the accessories are in the package. So this is a very successful story that we are working with the end users to come out the AI solution for them. This is for smart factory. Another example is for security robot. If you actually we work with the Japan company. They built out this security robot, and it will be deployed in the 2020 in Tokyo Olympic. Because we know that there are very few securities in Japan. So at night they send out the security robot to patrol all the facilities. And in this, they use the Core I, the CPU, and with the 8 mirrors inside because they connect the 8 USB cameras. And these 8 USB cameras will check all the facility and build up the 3D map so they can patrol. Okay, so this is another good example. If you go to the Japan next year, you can see this security robot. Okay, after we talked about all these applications, and there's one question customers will ask us: how to choose the edge devices? So actually, we AAEON, we share our experience, and we categorize the four performance levels. The first one is that if a customers want to do the defect inspection, we propose them to use the Xeon with the 8 Mirrors. So this is a very good performance customers can use. If a customers want to do the surveillance or security, they can use the Core I with the 2 Mirrors, fanless. And third one is the middle performance. They can just use the Core I because embed the GPU inside the Core I is very powerful as well. If customer wants to do the license plate recognition, they can use the Core I only. And for basic performance, for people counting, for traffic flow monitoring, they can use the upper lake with the 1 Mirrors. Okay, so the AAEON actually developed a lot of the Mirrors, the products. The first one we design is the AI Core X, which means that the form factor is a mini PCIe, and one Mirrors, the VPU is in that. So this is mini PCIe, so they can implement in different AAEON CPU boards or systems. So very easily for customers to extend their AI function. And the second we do is the M.2 form factors. We call that is the XM2280. So the form factor will be the M.2 the 2280 form factor. There are 2 Mirrors inside. Okay. The third one developed is the PCIe form factor, PCIe by 4 form factor. They will we designed the 8 Mirrors in that. So these car modules are very powerful. So we put that, install that inside AAEON boxes. The first one is the top performance. We can use the Xeon with the 8 Mirrors inside. So if you can see that our box CTA41M, they can support Xeon CPU or Celeron CPU. And they have the 2 mini PCIe by 8 slots inside, which means that they can install 2 the HDDO cards. Okay, and we also designed the 5 LAN ports, Intel LAN chip, the i211 on board. Okay, so customers can save the cost of buying PCIe by 4 LAN cards. And we also have the removable hard disk. Okay, so in our boxers, actually, it's very flexible to extend Intel Mirrors. They can use the 2 mini PCIe, the Mirrors cards, or they can install 2 the HDDO cards. Okay, so in the newest the driver, we can support the 16 the Mirrors. So you can see that if a customer uses the Google Net, they use the TensorFlow. The image is the 640 by the 480. In our test, for 1, which means the 8 Mirrors, the frame rate per second will be the 720. If we install 2, there will be the 1,440 FPS. So it's very powerful for a customer to use. And for top performance, what we do is we use the Boxster 8320, which can support the Core I, the CPU, and here is very important key feature. It's fanless. It can support 60 degree, 2 Mirrors inside, and without throttling. This is very important, without throttling, because we know that the Mirrors they will generate lots of heat. So by our advanced thermal solutions, we put that we use the newest technology, carbon water, the technology, the inside, and we can make the whole system is fanless, 60 degree, 2 Mirrors without throttling. So these are very good products for industrial automation. The basic performance is the Upper Lake with the one AI coax. There is the 1 Mirax. So we also design. They can support the Upper Lake, the CPU, and the key parameters is it's fanless. They can be around 55 degrees, 1 Mirax without throttling. Okay, so after we talk about all these AAEON AI edge solutions, also I summarize that. We provide the 4 levels of performance products to customers. They can use the Xeon with the 16 Mirax. They can use the Core i with 2 Mirax, and they can use the embedded GPU inside the Core i. And for basic performance, they can use the Upper Lake with the 1 Mirax. That's all my presentation for AAEON. Thank you very much.